Hey everyone, thanks so much for joining us on a very special episode of Speciale Talks. In this conversation, we'll be delving deep into the fascinating world of synthetic data. You see, we live in a world of data abundance. However, as data-driven decision-making becomes the cornerstone of industries today, concerns around data privacy, security, ironically, are leading to data silos. Businesses are increasingly needing to navigate the landscape of regulations and ethical considerations, and this is where synthetic data becomes necessary. And who better to discuss this with than Vyas? Vyas is a professor in the Department of Electrical and Computer Engineering at Carnegie Mellon University and is affiliated with the Scilab Security and Privacy Institute. His research broadly lies at the intersection of networking, security, and systems. Vyas is also co-founder of Rockfish Data, a synthetic data generation workbench that's building upon foundational innovations at the Carnegie Mellon University. I'm so excited to learn from Vyas's experiences through the course of this conversation. Let me now hand over to Arjun Rao. Arjun is co-founder and partner at Speciale, and he will take forward this discussion. Arjun, over to you.
Thank you so much, Ankita, for the introduction and the background. Likewise, I am amazingly excited for today's conversation of Speciale Talks. Just as a quick background for the audience, Speciale Talks is a series of conversations we have with early stage entrepreneurs, operators, domain experts in the world of enterprise software, infrastructure, and cutting edge tech, right? We do this to share learnings, to understand, what the trends are in the ecosystem and where the world is moving in exciting areas on a regular basis. This is part of our series of talks as Speciale Invest. We're an early stage venture fund investing in deep technology ideas, hardware and software, enterprise software with AI, data infrastructure, etc. On the hardware side, we invest in companies in space technology, robotics, EV, climate tech, variety of, again, bleeding edge areas that are impacting the world as we speak, right? We operate out of India between Bangalore and Chennai, but are helping and partnering with entrepreneurs building for global markets, right? And in today's context, like Ankita has set the stage, we're super excited to have Vyas Shekhar, right? Vyas, welcome to the program, and thanks for taking time for the conversation.
No, thank you for having me. I'm excited to be here and share what I know about the space and learn about what you have seen from your side of things. Thank you for having me.
Lovely. Thank you so much. Just a headline, maybe we start with a little bit about your background, right? You went to IIT Madras and then you did your PhD at CMU. You're, of course, Tan Family Chair Professor at CMU today, working on really cutting edge areas in, I think, combination of synthetic data as well as security, as well as data streaming. You're also co-founder at Rockfish, right? There's a lot going on. You're also chief scientist at Conviva, right? Just tell us a little bit from a background perspective, right? Maybe even taking us back to IIT Madras and your interests and why CMU and what you started doing there.
No, that's great. No, happy to share. As you said, I think I did my undergrad in IIT Madras Computer Science. Came here to the US for my grad school, did my PhD at Carnegie Mellon. Why Carnegie Mellon is like, at the time, basically, it's like Carnegie Mellon, the top ranked school. Had heard so many great things from seniors and other people who have gone there, and has like a wide reputation both in India and abroad, right? As like one of the top ranked computer science departments since the early 60s. It was like one of the first computing departments, the first school of computer science, has been like a sort of a pioneer in many aspects of computing innovation, everything from robotics to AI, a lot of the leading edge technologies. If you heard of things like the self-driving cars, the birthplace of AI, chess playing programs, NLP, all of them will trace their intellectual origins to Carnegie Mellon. So I'm extremely privileged to have been both a student there and now as even more privileged to be a faculty member there. And Carnegie Mellon is like a brilliant place to do research. right? I think people talk about the ivory tower, but the nice thing about Carnegie Mellon, it's an ivory tower, but also grounded in the reality of doing things that matter, building actual artifacts that work. And a lot of the mottos of the founders of Carnegie Mellon resonate with a lot of us as faculty and students there. It's called that my heart is in the work, as being like the founding motto of like Andrew Carnegie, and it sort of is in the DNA of like CMU. And the other thing I would like to say about CMU, which is interesting, is like it's one of the few places that is actually genuinely collaborative and collegial, in the sense that you will see these interesting cross-disciplinary, cross-domain collaborations between people in security and AI, between networking and security, between networking and IoT, between networking and embedded systems. And that's a unique place where those kinds of like cross-connected, cross-cutting research tends to happen. Happened for me in grad school, continues to happen for me as a faculty member. In fact, the things you mentioned, right? So here I get to work on cutting edge problems in networking and security, in streaming data technology and machine learning, synthetic data. All of these things are in part because of the collaborative, interdisciplinary nature of the research we get to do at CMU. So we are not siloed in any particular way. There's no like kingdoms that work on some X and Y cannot touch or encroach that kingdom. So I'm extremely privileged to have been part of that collaborative atmosphere, right? So you want to work on a particular problem space, solve a societally impactful problem, and you know what? The world's expert on the topic is like down the hallway from you. You can just go have a fun conversation, start a new research collaboration, right? Start whiteboarding, start doing things. And the students come in and drive you in interesting ways too, right? A lot of these cutting edge, cross-cutting stuff. And I'll give you an example of even the synthetic data collaboration, right? Came about in a fairly bottom-up fashion, right? So a lot of these interesting interdisciplinary work happens because new students come in, and the new students push you in new directions. They say, hey, I really want to work at the intersection of X and Y. I like your research. I like this person's research. What if we could combine ML and networking? What if we could combine ML and security, right? And indeed, the synthetic data work, the work that we did on generative adversarial networks was a result of that cross-cutting collaboration, where a new PhD student came in, Zenon Lin, fantastic, phenomenal researcher who's now a researcher at Microsoft Research. He came in and said, hey, I really like your work and Julia Fanti's work. And Julia is my co-founder at Rockfish and like a rock star in the machine learning and privacy space. And he kind of created it, right? He said, okay, I want to work at the intersection of both of your styles of work or both of your areas of expertise. And then he started brainstorming about like, what are the interesting problems and things in that space. So again, that to me is in the DNA of the place, right? We talk about CMU. The interdisciplinary collaborative nature is what spawns these kind of like cross-cutting activities. You get to work on cutting edge problems and that span many areas. I'm grateful for that.
Oh, lovely. Thanks for sharing that insight. It almost sounds fascinating to understand the DNA of the school, right? It seems entrepreneurial in nature, at least, which is what fascinates people like us, right, in our world. And obviously you have therefore also crossed over between and done that crossover between academia and entrepreneurship and real world applications and impact. So that thanks for sharing that, right? Maybe just go back a few years through your PhD and then post that and specific areas. How did you stumble upon specific areas of high interest that you double click on and that you've spent most of your time over the last few years, right? Including with the particular overlap on, the field of machine learning began and then generate synthetic data.
Great question. And I think it's a fun question, right? It's always useful to understand like the intellectual provenance of something that comes about. Ideas don't come in a vacuum. They have like a provenance and a history behind them. So when I started off my PhD research, I actually was working in like computer security and computer networking, right? So I call myself an accidental AI researcher, right? So I stumbled upon this field. My PhD research is in like network monitoring and network forensics. security forensics is where I started doing my PhD research. And the sort of the two ways I would characterize any research problem I worked on really stems from two, I would say, like two root causes, I would say, or two sort of root ideas. So one is what I call a pain point, right? Somebody has a fundamental pain point. It can be somebody in industry that you talk to. So we did a bunch of internships. We would talk to people in the telco industry and say, hey, what are your pain points? It's like, oh, okay, network monitoring is a problem. We don't have this kind of data. We can't build these models at scale. So it's a pain point, sometimes of a practitioner, but sometimes the academics are leading indicators of pain points, right? And I'll give an example of like how Spark came about. Apache Spark that everybody uses was actually not an industry pain point at the time, it was an academic pain point. There was a PhD student at Berkeley trying to solve a machine learning problem and said, dude, this thing doesn't scale. And his colleague who Mate happened to be next door and said, oh, look, okay, I can make it scale for you. That is the intellectual provenance of Spark, right? So sometimes the pain points, at least in academia, tend to be leading indicators of pain points that the industry finds later, right? Synthetic data is a good example of that. And in fact, so the intellectual provenance of the synthetic data stuff is a 20-year-old frustration for me as a researcher. Right? When I started doing my work on network forensics, we were developing all these algorithms for detecting attacks, algorithms for detecting how what was then like very worrisome attack called an internet worm. Right? We were saying, okay, how does an internet worm propagate? How do we detect and block it? And we were developing sort of some of the cutting edge algorithms to detect those attacks and detect those worms in real time. This is part of some of the earliest papers I wrote in grad school were on this topic. And
what year was this, if you don't mind?
This was 2003.
Okay, very
first project in grad school. Trying to do how do we detect worms in real time. Okay, now I'm dating myself now, but yes, 2003 was when I got into grad school, right? So I think it's really a 20-year-old frustration, 15-year-old frustration that led to this whole body of work. And the minute you come up with these algorithms, you're like, okay, how do I evaluate these algorithms? Because I need data to test these algorithms, right? I come up with a cool algorithm. I have no idea of validating if it's going to work in the real world. So I don't know the structure of the patterns that the real traffic has. I don't know the structure of the patterns the real attack has. And I'm like, wait, I could come up with the best idea in the world, but if I have no sense of how it works in the real world, how am I going to prove or disprove or validate any of my ideas? So we've had this problem in the academic side that we can come up with cool ideas, but there's no way for us to validate without the real traces, the real network traces. And this has been a problem in academia for a very long time, right? And as the world, as the introduction said, we are moving more towards a data-driven world, which means that every part of operations in networking, in security, in every single domain you can think of is moving to a data-driven approach. And the same trend is also happening in research. More and more research, you see cutting edge research in leading networking security conferences tend to be data driven, right? So they say, okay, I'm going to develop a novel ML algorithm for detecting blah, or improving the resource efficiency of something else. So what happens in that space, and this is the pain point we as academics face, is a lot of these data driven research becomes an intellectual dead end. Because if the data sets are proprietary, there is no way for somebody else to prove, disprove, validate, extend, or build upon the research that was done. So without the data, we are basically fundamentally hampered, right? I might have the best idea, I cannot validate it, or I see this paper, I want to just check that reproduce that research, right? Reproducibility is a fundamental aspect of science, and today we have a reproducibility crisis in academia. We've always had it. It's much more stark now because the world has gone towards more and more data-driven stuff, right? So maybe 30 years ago, people were doing theorems on whiteboards and say, I can reproduce a theorem. Like, okay, I can go through the steps, validate the algebra. Now you have an ML algorithm. How do I prove or without the data, check your workings, right? It's like show you're working in a test, right? It's like, okay, my working is an algorithm. Without the data, I can't do anything. So that's really what prompted us to start working on this space. For a very long time, we've been looking at how do we do test traffic generators, workload generators that help people reproduce the research. And around this time, so back to your question about synthetic data and GANs in particular, right? So the idea of synthetic data is not new. It's been there ever since people have tried to do anything, right? So I've written synthetic data generators back in 2003 when we were doing this worm research. Is I write my own handcrafted traffic simulator generator for generating this kind of stuff, right? So people have done, everybody has written at some point of time in their life, some test workload generator to test out their ideas. That is synthetic data. But the problem with that approach is not scalable, right? Anytime a new requirement comes up, anytime a new workload comes up, the human expertise, the domain expertise to generate a new kind of workload generator for new use case is extremely high. And you have no way of capturing that. The world is getting more complex. And what in the sort of the research world we call high dimensional relationships, right? It's not just A is correlated with B, A is correlated with B under some special conditions. So these are called like high dimensionality of relationships. There are many complex combinations that matter. So the more high complexity, high dimensionality comes in, these handcrafted generators become obsolete. There is no way for me as a human expert to capture all this complexity that's going on. This is where we actually saw this amazing opportunity of this really cool idea called GANs, or generative adversarial networks. And this was a breakthrough in the machine learning, actually more specifically in the computer vision literature, right? It was this very cool idea by, I believe, Ian Goodfellow came up with this for the first time, was they could generate hyper-realistic photos. I could give it a corpus of faces, or I could give it a corpus of dogs, and somehow this thing would magically learn what is a dog, what is a face, and you could ask it to produce new faces or new dogs you've never seen before. And you as a human said, hey, that looks like a face, that looks like a dog. And in fact, if you think about it, what is a dog or what is a face, it is a high dimensional relationship, right? A face should have like two eyes placed in that point with a nose, a mouth, with maybe sometimes glasses, sometimes hair, sometimes no hair. These are all the high dimensional relationships that go on in a face. And this was a breakthrough. Again, yes, they were doing it in faces, for faces mostly, right? And faces and like a lot of the images where they started off with. So we saw this connection, which was like, hey, okay, I'm a networking researcher, I'm a security researcher. The kinds of enterprise data we see are not really human faces or celebrity faces or cars or dogs or cats. What we have are like logs, events, metrics, packet traces, and other kinds of like network traces that people want to build models on. But that was like the aha moment. It's like, okay, there is a connection between generating a hyper-realistic face and generating a hyper-realistic workload generator for these kinds of enterprise network security use cases. So that's the aha moment. And that's the student who came in and said, I want to work at the intersection of machine learning and security. And then we started brainstorming about, okay, what's interesting opportunities? And I said, oh, by the way, I've had this pain point for a very long time, right? Ever since I started in grad school, I've always been stumped by the lack of availability of data. And I know I am collaborating with a bunch of industry people. They can't give me their data sets. And I work and collaborate and write papers with these industry people. And then the other researchers come and complain to me, dude, where's your data set? Right? And I say, okay, look, why not? There seems to be this cool new hammer in our toolkit called GANs. Why don't we try and see if this can help? This is like a chance, one of these, like, let's throw this idea and see if it works. And connected the dots between the power of GANs for images and taking it to like sort of real other kinds of production use cases. This was around 2015, 2016. So this is why I said like it's like a 15-year-old frustration bubbling up towards leading up to this problem domain.
Lovely. No, I think great context there. A lot of interesting nuggets of how we're connecting to areas, etc. And of course, along with all of this is what is happening in the world is, like you rightly said, the data explosion. One, and second, obviously, the movement of AI that is getting furthered and furthered. Right? You want to overlay a couple of these things into the similar timelines, and again, maybe therefore zoom into today's world and say, hey, where are we in AI today? Right? What from an evolution perspective and the kind of problems AI is attempting to solve has just recently solved, or at least is showcasing that, and therefore what makes this time sort of so unique?
No, that's a great question. There's a really fascinating paper. I think the folks at Google wrote. It's called The Unreasonable Effectiveness of Data. It's a very fascinating read about like the evolution of like data-driven, ML-driven techniques in the real world. And so they sort of their sort of brain, again, I'm paraphrasing their insight here,
Sure.
was that okay, in the 1970s and 1980s, people created all these like bespoke complex algorithms and models to solve their task, right? But then what happened later on is like, okay, there is this really fairly simple idea called a neural net that was in like the back burner for a very long time, right? In the 80s, there was an explosion in the neural net world, and then it kind of died down. People like, okay, we've hit the limits of what this can do. And it was slowly going in the back burner. It was like kind of a second-class citizen even in the ML world. And then sort of this explosion was like, oh, look, in like the early 2000s, late 2000s, and so on, we're like, suddenly with the explosion of compute power, and especially things like GPUs and big data computing and distributed computing, suddenly you can revisit a lot of these classical assumptions that were wrong or were wrong at that time, right? So we were like, oh, look, two things. One, there was never enough data to train these things, deeper networks, right? The amount of data needed to train a deep network far exceeded the data we had. So it is kind of like, okay, I can't do anything. Second, even if I had the data, I don't have the compute to train it. So that was the inflection point, that the ability to collect the data at scale and the ability to process the data at scale kind of converged as this unique inflection point, I would say, around the 2000s. This is where you see the big data plus GPU plus machine learning explosion. This is when the Unreasonable Effectiveness of Data paper was written, saying, look, now we can revisit a lot of these classical, what we thought were hard problems: speech, text, vision, right? And we were going on this incremental path of incremental improvements, and suddenly you have like a quantum leap of improvements, because I can now process 100x more data with 100x more compute, and suddenly the world changes. So that is sort of this interesting inflection point. And sort of GANs are in that sort of, if you think about the kinds of problems we do were classically things like classification and synthesis, or even like saying, okay, sentiment analysis and those kinds of stuff. And suddenly you have this new abilities like, wait, I can generate stuff, right? So generation is the next quantum leap from classical problems to, I don't just need to understand, I can actually generate. So if you think about GPT, the G in GPT is generative.
Yeah.
Right? It's gone from the point of just understanding and classifying to actually generating stuff. So that's sort of the other kind of, even the GAN, the G in GAN it's a generative adversarial network. Adversarial happens to be a particular way of training a network, but there are other ways of training a network as well. GANs were the sort of the OG, the original generative model, but then subsequently there have been other things that have also come about, things like transformers, and you've probably heard of like transformers. That's like all the rage right now. Things like diffusion models that are also extremely popular right now, and there are also like sort of domain specific models that arise in a domain specific context as well. So what's happened is this explosion of data connected to the explosion of techniques has made us rethink a lot of what we thought was traditionally not possible, right? Speech to text was thought not possible. Text to speech was not thought possible. Speech comprehension was not thought not possible. And now suddenly you can revisit all of these assumptions and say, I can build deeper models, train them. Of course, I mean, there is obviously a cost with that, right? It doesn't come for free.
Of course.
So there is obviously the kind of investments you're making in like, hey, how do I do hardware, edge, better training, all this kind of stuff are very relevant. But the thing is, we've gone from a 0 to 1, right? We thought this is not possible, now it's possible. Now it becomes an optimization problem. How do I make it better? So that's an interesting inflection point, I think, in how a lot of even the academic community, research community is reacting to it. It's like, wait, this was possible. I didn't even know this was possible. Now suddenly you have a new capability.
Got it.
So, and I think that is an inflection point for us for sure. And we're scratching the surface of the inflection point for sure.
That's so exciting. That's so exciting of course, for all of us, involved in this or being in and around and looking for opportunities and to solve these problems. Maybe a very laymanish question from my side on, yes, there is on one side explosion of data, right, which can therefore enable training of different types of new models to do new things, right? But at the same time, you are saying it's very hard in different contexts to use that data effectively in some sense, right? To prepare that data, to have it relevant, to have it shared, and use it, right? Who wants to train, right? Obviously, privacy security is of very high discussion topic and relevance and importance, right? And hence, sort of, right, how do we reconcile these two? There is, it's like, water all around us but not a drop to drink sort of situation, right? And there must be other ways and other solutions that people are trying, and we'll keep looking at ideas and entrepreneurs or saying, hey, how can we solve the data masking, security, privacy, so that it can be better used for AI? So just talk about that, and then why do we still need synthetic data? I'm trying to play devil's advocate just for
no, that's a great question, right? So again, I think when I presented this sort of rosy picture that data is everywhere, I think that success of like public data sets that are there everywhere is mostly when it comes to things that are like public on the web. So you think about text data, I can mine the web, I can crawl the web, I can collect all the data that's ever been written, or I can go to the library where all the sort of public books are available. I have a lot of data to train and build models for text. Similarly, for images, again, there are public data sets for images that are available that I'm able to build stuff on. Now, that being said, those are what are visible in the public domain, because there's a data in the public domain. I built a public domain model based on the public domain data. But the truth is, when you actually think about enterprises, the kinds of data they deal with are very different. It's not just public documents of text and images. There is often like proprietary text and proprietary images and other kinds of data. They often have like measurements, events, logs, traces, tables, all these other kinds of data that don't quite fall this like, oh, let's crawl the web and build a model type of use case. So even though like the machine learning has gotten to the point where if the data is available, you can build those models, there are often these practical constraints where because of privacy, because of compliance and other organizational policies, you do not have the data you need in the right place at the right time. In addition to the data privacy and those kinds of problems, there is also an issue of like what I would call like data sparsity. Oftentimes, when you're trying to build a new model or make your model robust, it's not so much I want models for the common case, but I also want models that represent some of these sort of more anomalous or unexpected use cases, right? So here's an example, right? Okay, suppose and I'll give an example of like images because it's easy to think about. So you're wearing like sort of glasses, right? And say, hey, I built a model that works for people with glasses, but it has never seen people wearing, for lack of a better example, orange glasses, right? And suddenly, okay, wait, suddenly if I say orange glasses, it might mispredict and say this person is not wearing glasses because all my data set only had like fairly mundane colors of glasses like black or gray or whatever most of the glass manufacturers make today, right? So that's an example where you have data, but you don't have the right kind of data, right? To build a more robust model to detect if somebody's wearing glasses, you might say, okay, I also need these kind of like weird examples of like orange glasses and be able to generalize from sort of the more standard colors to other kinds of like colors. So in addition to the sort of the privacy compliance angle, where a lot of the data in enterprises is locked away, right? They cannot willy-nilly give it to GPT and say, hey, take all my data and train it. That's not going to happen, right? And there are transactional costs and transactional bottlenecks, right? Even say two vendors, customer and provider, actually have a collaborative agreement. They have a contract, but they cannot share the data because of privacy reasons. This is something we hear a lot, right? So say a customer reports a problem and the vendor is trying to reproduce the customer's problem in their lab. And they're like, okay, I don't know the customer workload. I am trying all these things to try and reproduce a problem, but the exact thing the customer saw, I don't have. 15 years ago, I could just willy-nilly pull the data, everything I want from the customer. Now I'm living in a much more privacy-aware, compliance-aware world. I cannot just randomly go and pull all the logs, all the data I want from the customer, right? So that sort of going back to a statement about there's data everywhere, but okay, when I want to drink it, I don't have the right kind of data, right? And that's kind of where we need a family of sort of an I would say like a toolkit of solutions, right? You have a family of toolkit of solutions, and synthetic data is an important part of the toolkit. There are other things in the toolkit, and I wouldn't say synthetic data is the only answer to that problem. There are other answers in the toolkit depending on the use case. Things like federated learning, things like homomorphic encryption, things like anonymization. They all have a place in that world when you say, okay, there are data silos, and I have a particular use case that need to be solved. And how do I best combine these different solutions to meet that particular use case? So, for example, the data sparsity problem cannot be solved by federated learning. If I'm trying to do new model exploration, that cannot be solved by federated learning, right? So if I have complex kind of queries, homomorphic encryption or homomorphic learning is not quite there yet. So this is where I think there will always be like what the term is like horses for courses, right? Like there is a horses for courses here. Like I have a particular use case, a particular scenario, and we have to create the best workflow for that particular enterprise use case scenario. And even though we've kind of the public view is like, oh, GPT has solved the problem, but the truth is they have done one thing at a massive scale really, really well, right? ChatGPT has done text on the web really, really well, but there's more to the world beyond just text on the web.
Yeah, and that's a great point you're making, right? Which also sort of is a good segue to say, you know, they were able to do that because of the freely available, abundant, easy to use, non-controlled or non-privacy controlled web data, text, right? That enabled them to do a fair bit of that.
And there's a little bit of a nuance there, right? It's unclear if some of that was actually non-controlled or should have been controlled or not.
That's a fair point.
For example, this is where there is some of the legal thing is a little murky, right? So you had something on GitHub and you had a particular license or a copyright thing. Is like, and yes, you can crawl it, but were you license aware, copyright aware? There is a little bit of a gray area there. So be careful.
And it is being discussed post facto today, while it has sort of gone into the model in some sense already, right? But it is being discussed post facto that how do they use which piece of data. Fair point, absolutely, right? Maybe in that context we extend, and I have two questions. One, of course, you know, how do we think about the complexity in obviously OpenAI, ChatGPT has sort of done one use case of text very well, but what about other types of data and therefore the need for other types of data, audio, video, images? How do you stack rank these in terms of complexity? Where are there more challenges? Where is more work happening, right? And where is probably more correlation to, is there more or less correlation to where synthetic data can be valuable? All right. Also, in all of this, it's very important for us to segue into, hey, Rockfish and genesis of Rockfish and specifically which pieces you're solving.
Absolutely. Again, I think all of the data types you said have their own intrinsic complexities, and each use case within the data set also has intrinsic complexities.
Correct. So that's the other,
for example,
way to slice
another
it.
Dimension is use case.
Type of data, but also what use case.
Yeah, there is a data set complexity and there's other use case complexity, right? So for example, I think even in I think text is easy because text is the most common thing, right? Even in text, you can say, okay, look, I'm trying to do things like sentiment analysis, or I'm trying to generate answers that create a travel schedule for you, or I'm trying to generate a travel schedule for you. Right? There are different use cases within there, or sometimes it says, oh, it can solve your whatever. It can pass the bar exam, or it can pass the medical exam because it's memorized all these answers, right? So there are these question and answer type use cases. So there is different use cases or different complexities or different levels of performance of these models. And then there is the data sets themselves have like intrinsic complexity. Like audio is a different beast than video, right? I referred to this term earlier about high dimensionality, right? The nature of high dimensionality in these different data sets is very different.
Interesting.
If I had like tabular data, which is not a lot of like enterprise data, right? I have tables in like Snowflake or Databricks. Or I have time series data where I'm measuring events or sessions or user journeys or other kinds of stuff, other kinds of like those patterns, right? Every financial company, every healthcare company, patient records, user records, transactions, or even like, so imagine we are on the Zoom call, right? somebody in the backend of Zoom is measuring all this network performance and network logs and network traces and making sure the service is running well.
Yeah.
Right. They're constantly adapting their algorithms and all this other stuff. So it's across the board, and each of those data sets and use cases have very, very different requirements in terms of the structure you want to capture, the fidelity you want for the use cases, as well as the privacy properties you want to preserve. Can be very different across different use cases and different sectors, right? So you can think about almost 3 dimensions. I think we said 2 dimensions, right? The type of data, the type of use case. There is also a third dimension, which is probably the sector or the market vertical, because there might be vertical specific regulatory compliance issues.
Yeah, which is where
that
the
arise.
application is, right? And who's the consumer in some sense, or where the consumption is going to happen.
Yeah, and that can be very different as well, right? So sort of the sector determines kind of the contractual limitations or the constraints imposed on the data generation. And then there's the use case. Like, am I trying to build a new model? Am I trying to test an existing piece of software? And we've heard a number of use cases where people want synthetic data for sure. And they have like, they're slightly, the underlying foundation is similar, but they're all slightly different in some unique way.
Sure. Got it.
And in terms of like intrinsic complexity, I don't know if there is like a theoretical limit, like X type of data is harder than the Y type of data. I think it also depends on the particulars of the data set, right? Some data set are like, okay, if I just give you like a sine wave, okay, there's nothing there. I can sine wave, I can write the one formula and I'm done, right? But now it just because it's time series doesn't mean there's an intrinsic complexity. There is an intrinsic complexity of a data set from a particular domain under a particular setting. That's where like a lot of the high dimensionality starts coming in.
Got it. Got it. Yeah, no, I think good time to delve into Rockfish, right? 2 ways I want to at least understand and learn. One, again, genesis of Rockfish, your association, your, interest in, solving that particular problem. What is the problem and what is the market that you're going after? I'm also on the other side, I'm fascinated and interested in you wanting to be an entrepreneur while you're in academics, while you're doing deep research. I know you have set the context of CMU already having that sort of a DNA, but please help us understand again this sort of a different role in life and in your career as well. Very fascinating.
Happy to share, and thanks for bringing that up, right? So genesis of Rockfish. So the genesis of Rockfish is twofold. So one is we were doing this academic project for a while, right? So we've been open sourcing a lot of the algorithms. In fact, the student I mentioned, Zinan, had open sourced his code Doppelganger, which became the de facto way people do time series generation, right? If you think about most of the other synthetic data companies out there, everybody out there is like, hey, if you have time series problem, go look at Doppelganger. I mean, that's kind of become the de facto time series model out there that everybody is kind of using. And we had put it as open source. I mean, at that time we had no, our goal was like, oh, this has to be used by many people, right? So we like put it open source under a liberal license and say, go for it. We'll help you.
So just for clarity perspective, Doppelganger was your, IP built at CMU with some students.
Correct. Yeah. So Doppelganger was a research paper that we wrote at the Internet Measurement Conference, where we showed for the first time that it was possible to do GANs for time series. And time series turned out to be this unique beast, right? Like you said, like complexity of the data set. You just take an idea for images and say, let me apply it to time series. Just doesn't work, because time series has a unique problems where, okay, there are temporal patterns you need to capture. There are metadata properties you have to capture. There are metadata measurement properties you have to capture. So naively taking the black box that was developed for images and applying it to time series, you will get like horrible results, right? If you give it to a domain scientist, they're like, okay, this doesn't make sense, right? X and Y should be correlated, but they're not correlated. Or X has a diagonal pattern, it's not showing up. X and the core auto X should have these periodicities, X that is not showing up. So that's the genesis of like Doppelganger, where we said, I know, again, this is me as a domain person. I was the first customer of Rockfish, so to speak, right? I was like, the challenge I posed to them is like, okay, I'm a networking person. I don't have images. Actually, I don't care about images as a networking person. Like, what I care about is like, okay, I have like things like time series data. Like I have events, I have logs, I have metrics that people are collecting all the time. I have quality measurements people are collecting all the time, like network latency, network throughput. And like, okay, let's see how far we can push these machine learning things to generate that kind of data. So that was the challenge I posed to Zinan. This is like his first PhD project, right? I mean, he kind of like, this is the beauty of PhD students is they come in without any baggage. This is awesome, right? And they can be ambitious. They're like, wait, they didn't know this was not possible, right? So he has to give the 20-year-old veteran this problem. They would have, I tried all these things, they don't work, man. They're like too cynical, too jaded. The fresh PhD is like, oh, cool, I'll try this. And he produces really brilliant artifact and very, very sort of foundational ideas on how to make time series generation possible using GANs. That was Doppelganger. And we'd open source it, and then we started building more on top of Doppelganger, looking at how to generate like realistic network packet traces. Again, coming from my domain, as I said, like I am the first customer of Doppelganger. I said, oh, okay, you can do that. Oh, fantastic. Now I'll challenge you a little bit more. Can you do IP packet header traces? Because that's been a pain point for everybody in the telco industry. People will not share IP headers or packet headers or packet traces, even though they know that's like very critical for downstream workflows. So then we started building a whole bunch of these things on top of it. Then another challenge. Oh, by the way, if I want to do some security testing, I don't just care about the common case. I actually want to generate like adversarial workloads that stress test other parts of the system. Oh, can you change your GAN to do that? And that was a paper called Rare GAN. How do you generate rare samples effectively using GAN? Right. So each one of these things is like a pain point or a problem I have, as a practitioner in the networking space, has faced at some point of time. So which is where this is the theory meets practice, right? So it's not like these problems are coming in a vacuum. As a practitioner, I have faced these problems in my domain for a very long time, and every time it's okay. And this is how research also works. Oh, you think you can do this? Okay, let me challenge you a little bit more. Let me challenge you a little bit more. And the sequence of challenges led to this body of work, starting from Doppelganger to some foundational advances in improving the learning properties, supporting rare classes, supporting new kinds of data sets. And we are doing this research and continuing to do this sort of research and push the boundaries of what is possible with this technology. Now, at the same time, we were part of and I should thank the National Science Foundation, right? So if you didn't know about like the way research works in the US, a lot of it is like federally funded by these organizations like the National Science Foundation and DARPA, and the internet was created by DARPA, for example, right? All of these things are funded projects funded by these federal agencies. So we were part of a National Science Foundation award where we were trying to explore the transition to practice from this idea, right? And that made us talk to a number of industry practitioners. So the intellectual provenance of Doppelganger, NetShare, RareGAN is all purely academic. It's like, dude, I want to solve the reproducibility problem. I envision a brave new world where every single research paper that is published will also upload a synthetic data set. So the next researcher can validate, extend, and build on that work. So any paper I write is not an intellectual dead end. So this is the noble academic ambition for why we got into this space. But at the same time, so the NSF grant, one of the things that they, and rightfully so, made you do is like, hey, okay, your academic goal is amazing. Why don't you talk to some practitioners as well? So part of the grant was to talk to a whole bunch of practitioners. And then we spoke to a number of our collaborators in industry across the board, right? And this is where Scilab, I'm part of CMU Scilab. We have a big and active industry partnership program that gives us access to a whole bunch of industry practitioners who come and visit and talk to us. So everybody from Intel to AT&T to VMware to Bell Labs, Microsoft, are all Bosch, Siemens, are all like sponsors and sort of collaborators as part of this initiative. So the grant made us talk to a whole bunch of them and said, okay, hey, we seem to have this hammer. Is this a useful hammer? We think it's useful because we as academics care about this hammer, but is there a useful nail for you guys, right? And that was the aha moment. And they're like, this is like a gold mine, right? Every industry we speak to, every practitioner we speak to has a version of this problem. They may have slightly different versions of this problem, but they're like, oh, I can't share my data set with my team. We also spoke to like people in like fintech, like folks like Chase, JP Morgan, those kinds of people, right? And they're like, and everybody gives you like, okay, I feel this pain today, dude. It's like I feel this pain today. I have a team in India, I cannot share a data set with them. I have an academic collaborator, I cannot give this data. I'm trying to build this model and I have holes in my data. the data is too sparse. I cannot build a better fraud detection model for myself, right? So that was the aha moment for Rockfish. Is like, okay, this is not just an academic curiosity that we have built that a lot of people are using. There is actually something where we need to take this and put it in the hands of practitioners across the board, across many industries, across many use cases. And that is the provenance of Rockfish. And so I should also give kudos to my co-founder, Girish, who's been an industry veteran in sort of the networking AI ops space for a very long time. I've known Girish for a very long time, and I would periodically use him as a sounding board, right? Like academics will come up with some ideas like, hey, look, I have this hammer, is there a nail? Right? So I like this hammer and nail analogy.
Yeah.
Academics very good at coming up with hammers, but sometimes you're building the wrong hammers, or the hammers are not ready for the nail yet.
Yeah, or it's only good for just one small nail. Right?
One nail, exactly. It's not a repeatable, scalable, or a monetizable nail, right? And this was the aha moment when I spoke to Girish. He's like, okay, look, every one of my customers has this problem. We are building solutions for them, for reproducing, for testing, for ML building. Every one of my customers has a version of this problem. We have this problem. The previous few companies he had worked at, and that really clicked for us, right? Talking again. This was not in a vacuum where we suddenly decided to take the plunge. We sort of did this, again, not like market research in the formal way that you guys do market research, but this was like this, okay, informal set of signals that we got that this is not just like a pain point we sort of imagine for ourselves. This is a real world pain point that is like across the board, across industry, across use cases. And that's when we sort of, that is the commercial side of Rockfish is like, this we can't do just in academia, right?
Yeah.
This takes a different cadence of effort, a different type of effort to put this in the hands of the practitioners. It can't just be open source and lo and behold, please use my open source. It has to be to the point where we make it usable and addressing the pain points of the actual users, not just like, okay, upload a model to Hugging Face and try it out. That doesn't quite cut it in that world.
Got it.
So, sorry, long-winded answer to your question.
No,
but that was sort of the provenance and genesis of Rockfish. And to your point about like wanting to be an entrepreneur, that was the second part of your question. I'll come back to that. That's an interesting question. So when I graduated from grad school, I actually didn't know what I wanted to do. I tried everything. So I was like, okay, I know I like research. I like the intellectual stimulation of being in research. I like the intellectual stimulation of being in academia. But there's a part of me is also like, okay, look, yes, we also need to make this impact where this gets in the hands of people. Writing a paper by itself is not the end goal. Again, in academia, our products are papers and students. That's the legacy we live and die by, right? These papers take their impact, and the students we create are the impact. Like the students who are like now leading researchers at various universities and research labs, they are our strongest sort of impact. But there is also this thing is like, okay, this idea the ideas will die in a vacuum unless you take the initiative to take the idea and take it to the next level. So, and that's something I've always wondered about, but through the academic career at various points, I'm like, okay, it's like now's not the time, now's not the time. And the timing also worked out where this seemed like the right place, right time. The AI train is really taking off. And there's a lot of use cases that we're hearing from the people. And that's how we decided to take the plunge. So I was like, and this is a nice mix for me is I get to see the cutting edge problems from the practice and from the academia. And there's this really interesting cross-pollination between my roles at CMU, Rockfish, and Conviva, which is very interesting. So there are problems at Conviva that can be solved by Rockfish, problems at Rockfish that can be solved by Conviva, and problems with both of them, which are like 5 years down the line, that will be solved by CMU. So this interesting cross-pollination of things where you see it's also like different timescales of innovation, right? The small disruptive companies versus like a more established company versus like the academia are all doing like R&D and innovation at various different scopes and scales of innovation. So
very fascinating.
And that is a very fascinating. I didn't know this going in, but this is more a reflection of like having done 1 year of this is also a good time for me to reflect and tell you what I'm learning from that.
No, thank you. Thanks for sharing that. And in that context, maybe we just double click on, because you mentioned Conviva, right? Which is, of course, in its own space in data streaming in real time and building that infrastructure. Talk to us about two things. One, because underlying all of this AI evolution, need for synthetic data, proper training, better training, etc., is again preparation, readiness, and then pushing through of data, right? It is data, right? And the data infrastructure stack, as we know it, as we see it, is evolving as we speak, right? Because it needs to, because the demands are changing overnight, literally, right? And therefore, there is need for certain types of infrastructure, certain types of readiness. So help set some context on the data infrastructure side and your vantage point, and therefore, hey, what is Conviva solving? What are you most excited about? How are you involved there as well?
Yeah, no, great questions, right? As I said, like models or ideas are only as good as the data that comes into it.
Yeah.
And the hidden sort of dark secret of all ML is that if your features are terrible, you're going to be terrible. So I think your model is going to be terrible, right? So there is a big aspect of the data infra, and beyond just like feature engineering and feature learning, it's the whole ML ops workflow, right? It's data quality monitoring. It's about data versioning, model versioning, and making sure like there are no gaps in your data, the features are actually valid, and so on. And also building more robust models, right? So there's also this whole, I would say like the coming of age, right? It's like we were in the teenage years of AI, and now it is to get ready for prime time. You have to solve all the hard problems that is like, okay, we're not quite done yet. And that's where the data infra comes in, right? How do you do this at scale? How do you do this in real time? And how do you sort of make sure you can process all of this like event streams coming in at scale? And a lot of the times, and this is kind of what we're seeing at Conviva, is that the world is going a lot more into the streaming model, right? Earlier, it was like data at rest. You put everything in a database and so on. But more and more, we see like the world has to go to like a low latency world. It's data in motion. You want to do ML at the edge in real time in a stateful way. Those are now pushing the boundaries of where classical big data technologies cannot support them anymore. And those are the kinds of things we are sort of doing at Conviva. It's like, okay, pushing the frontiers of stateful streaming processing to support the next generation of operational workloads that people are running at scale. And we know that the classical big data techniques that we have used, and it served us well for 30 years. Now it's like, okay, it's not going to work anymore, right? You can see all these trends of people as like, well, look, my cloud costs are like my cloud costs and my cloud observability costs are way bigger than my infra costs.
Yeah.
And that's the world we are in right now, right? For a while, hyper growth was okay, great. And then now profitability is key. And suddenly you say, okay, the infra and my cloud cost, my database cost, my Snowflake bill, my Datadog bill is too high.
Yeah, everything is ballooned up. Yes.
Yeah, exactly. Right. And it's actually to the point where we are now building systems where we cannot make sense of them anymore. Our ability to build complex systems far exceeds our ability to understand and monitor them. That's the problem that Conviva is trying to solve, right? It's like, and that's where we're pushing the edge of pushing the frontiers of how do you build scalable observability and monitoring infrastructures for monitoring systems at scale. Now, the synergy with Rockfish is that, okay, so an important part of that whole workflow is building models, is building like shadow pipelines to test your models and data at scale. That's where things like synthetic data for those kinds of user data, finance data, telemetry data become very critical. So there's an interesting synergy there between the data streaming world and so on. And I would say like one common theme I see across all three of my sort of hats is like what I feel we are doing more and more is I would say democratizing this technology at scale. So for example, I would say the mission of Rockfish is really democratizing synthetic data for enterprise scale use cases. And I say democratizing, I actually mean it like lowering the barrier of entry for somebody to use it and democratizing across the applicability in the use cases. So sort of two dimensions of democratizability.
Sure.
Like saying, I don't need to have a PhD in computer science to be able to use it, right? And it can work for everything from sales demos to machine learning, model building, to model testing, to testing and incident response. So I want to have a general purpose platform that can serve all of these use cases that arise in a modern enterprise. So that's, I would say, like the theme of Rockfish is democratizing synthetic data at enterprise scale. I would say the theme for Conviva is democratizing stateful stream processing for enterprise scale. Right? So it's like democratizing really hard technology, making it easy to use and making it available to a broad cross section of the market. And similarly, on the academic side, I think we're building the foundations for this democratization. Right? So at CMU, I'm co-leading this initiative called the Future of Enterprise Security. And really the mission of that initiative is, okay, again, it's about democratization, right? Today, security is the purview of the super hyper privileged, right? The hyperscalers like the Amazon and then Facebooks and the Googles and the Microsofts are the ones that can afford like 24/7 expensive security teams to keep your things secure. What about the rest of us, right? So how do you make sure that we can actually democratize those capabilities? And AI is a big piece of that. So this is interesting synergy between democratizing data processing, democratizing AI, democratizing synthetic data to enable that future vision of security for all. It's no longer just the purview of the privileged. So I would say that's a common theme across like a lot of the research I try to say, okay, look, we build something, how do you democratize it across different, generalize it, both to users and across use cases. And each of these three things have like a different mission in the democratization angle.
Very interesting, like you said, the connections and the mix of things, how they're feeding into each other, and for a broader ecosystem also benefit. Maybe we just extend on that last point you made on security for enterprises, right? And of course, it is sort of one of the top few things being discussed across the ecosystem as parallelly the explosion of Gen AI use is happening, right? Adoption in enterprise is being happening, experimental as well as going into production. But there is that, I hope there is that healthy skepticism and caution of, hey, what does it mean? What are we compromising on this behalf? What are your views on that? With Gen AI adoption at scale, right? What is enterprise world vulnerable towards? Right? And what does one have to watch out for? And therefore, again, wearing the investor hat or the entrepreneurial mindset, what are the opportunities? What are the big ones to solve for if we just look slightly ahead?
Great question. And I think you're thinking in the right angle. So maybe there's two ways to sort of break that problem down, right? So one way to think about is like AI for security.
Yeah.
And then you can think about like security for AI.
Yeah.
So there's like sort of duals. You can think of like a dual problem, right? How can AI help security? And then second problem is like, okay, what security for AI mean, right? And maybe we can take both of those things in one way to think about it, right? When I think about AI for security, again, goes back to the future of enterprise security mission I talked about, right? So today there's a lot of institutional wisdom, institutional playbooks, automating vulnerability assessment, these things can potentially be automated, right? To the point where we don't need like a large team of experts to monitor a large scale network. Attacks are getting way too sophisticated for a human scale intervention, right? So that's something that AI can potentially help, right? Automating configuration repair, patching, automated identification of vulnerabilities, even new capabilities like cyber deception, right? This is something that we can do, and we're actually working on at CMU. Is like, okay, what if I have an AI-driven cyber deception, which is I can throw decoys to lure attackers and break them, or find out and do recon on what they're doing. So you can now think about new capabilities we didn't have before, right? So now you can think about, okay, it's like almost think about a game of chess, right? The attacker is playing one game and we can play a game against them. So you can actually start playing these sort of cyber war games or cyber war scenarios. And I think we're already seeing primitive versions of them playing out, right? In a lot of these settings. Now, how do you formally think about those things and reason about them? That's going to come. Now, there, I would say we're scratching the surface, right? When you do AI for security, you have to think about, okay, is it safe? Is it trustworthy? Is it explainable? Ultimately, a human operator has to make the call and say, is this a safe approach, right? Do I understand the consequences of what I'm doing? And do I understand the safety? Does it compromise my other safety postures, my other security postures? So we need more reasoning systems, explainability systems to make it trustworthy for operations, right? So today, for example, a lot of the security now is basically a data-driven monitoring game, And the biggest problem right now is things like false positives. People are like swamped with false alerts and like false leads and sometimes false negatives, like the blind spots. AI can potentially help with those things by building more robust models or providing more evidence of what's going on. That's something that AI for security can help. But open challenges there will be speed, scale, trustworthiness, explainability, and to the point where say, okay, would a CISO be willing to adopt that AI for security solution and let it run? Right? You think about like a security co-pilot almost. I don't think it will be a security autopilot yet, but at least a security co-pilot is a good vision for us to aspire towards. Now, the flip side, there is security for AI, right?
Yeah.
It's like we have to secure the AI infrastructure we are building, right? I think one of the things is like, and that is a complete cross-cutting, cross-stack problem. It goes everything from the software supply chain, right? If I put a vulnerability in the model, if I put a vulnerability in NumPy or PyTorch or whatever, then like the whole world is going to collapse, right? And this is not a hypothetical scenario. This can happen. People have shown proof of concept vulnerabilities of you inject something, some backdoor in an open source thing, and it will have like a downstream consequences much in a subtle way. So there is a security for AI is a cross-cutting thing. You have to secure the entire stack because now, as I said, like our ability to build these systems far exceeds our ability to understand them. And that's going to be the challenge for these things, for AI, right? It's like, okay, I have a 80, whatever. I don't know what the latest benchmark is, like 70 billion parameter or 170 billion parameter. You're building these monsters that we cannot understand, right? No human brain can comprehend what this thing does, which means that we need other kinds of techniques to understand what these things do, explain them, make sure they are fair, they are not biased, they are transparent, they can explain their reasoning, right?
And in a simplified fashion. And in a very simplified fashion as much as possible, at least in the real world.
Exactly, right? Like hallucination is a big thing, right? People are building, and we've seen this too, like people are building like, okay, here, I will help you build like a co-pilot for doing some FAQs or like documentation reading or like some things. And I'm like, wait, do you know if it's correct? Like just because GPT told you doesn't mean it's correct, right? That thing is prone to hallucination. So no problem. I mean, they will tell you that. It's not like they're hiding it. They will tell you this too. It's like caveat emptor, right? Buyer beware. It's like you should. It's like, and one of the maxims in security is like trust but verify, right? You can trust it, but you need to verify if the answer is correct for your scenarios. On the security for AI, the privacy is a big problem, and also things like traditional security capabilities we want, right? Think about like what is like the equivalent of like a SIEM engine, a security incident event monitoring engine. What is the equivalent of like things like RBAC or role-based access control? What is the equivalent of like the principle of least privilege? These are all like classical security axioms and principles we've come to know in system security. We'll have to think about what does it equivalently mean for our AI things, right? So for example, you say you're building some new enterprise GPT product, and I'm like, wait, if you view it through the lens of least privilege, it's like how much access does the model need to have to my documentation? Is there a way to compartmentalize it such that it only gets the least amount of privilege it needs to answer my query? So there are all these like sort of classical maxims in security, and I think the time is right for us to revisit AI through the lens of classical security concepts. And there are people working on those things, right? And there's a lot of work also in like what's called like adversarial learning, adversarial ML, which is how do I generate adversarial samples that beats the AI? And there's an active body of work in that. And that's really sort of helping strengthen and sort of, it's like bug finding for AI. Think of it that way. Right? It's like a fuzzing for AI or a bug finding for AI. And that body of work needs to continue and needs to be actively encouraged to make these models robust. Right? You shouldn't shut it down because somebody found a vulnerability in ChatGPT. It's like, okay, look, let's go fix it systematically, put the guardrail.
It's basically white hat hacking in some sense, right? Because you find it yourself before somebody else externally finds it.
And all these are like active bodies, active topics of research going on everywhere, right? And I think we are still in early stages. I think by AI for sec and security for AI are by no means solved. And as you said, all of them will need data infra, machine learning, and synthetic data, that synergy to help solve those kind of problems.
That's
will not be done. The good news is, the good news from an academic side is will not be done anytime soon. So
no, that's fascinating. It's how you're tying it back into how that all that capability and infrastructure will be needed to get to solve for these upcoming challenges, right? Maybe we use that to peek into the future a little bit, right? From your perspective, of course, we are in the middle of things. You are, on the research side as well as on the entrepreneurial side. You are at the cutting edge of things. So you are building for future, today's problems and tomorrow's problems. But if you have to break down for you, because you're also sort of at the mecca of innovation, right? You're at CMU, you've been there, you've seen so much amazing stuff. And sometimes it's super early, but then the time is right. Like you said, an inflection point arrives because of some other ingredients. And you've seen this evolution 15, 20 years now, correct? With that vantage point, with that experience, how do we peek into the future? And I want to do one micro question, but one macro as well. Micro, synthetic data infrastructure, security. What do you envision? Do you envision really widespread usage of these toolkits, like you said, right? Any other exciting things on this particular front? Macro, maybe peek even further and generally give your view and opinion of what are some things that we are not imagining today, right? And we cannot fathom today that is quite likely, in your opinion, in the next, I don't know, 5, 10 years. I don't know. Time frame agnostic, let's call it that. I'm just fascinated to hear your side.
No, that's a great question, Arjun. And let me take the micro first. It's easier to go from the micro to the macro.
Yeah.
So my view of synthetic data, this is really the vision that sort of Rockfish is also building towards, right? So I don't think synthetic data is a curiosity. So the vision is synthetic data will be an integral part of every single ML flow in the future. Like every single MLOps pipeline in the future will have to have a synthetic data component. And it's whether it's part of a shadow pipeline, whether it's deeply integrated to the pipeline, those are all the verdict that will happen, but that needs to be done. But it will be an integral, continuous part of any data ops, ML flow, MLOps pipeline you will have in the future, right? So today it's like, again, for a lot of the things, at least I would say we're still in early stages of how synthetic data is being used. Some of the early use cases that people saw were in like mostly for like, okay, let me generate label data for our self-driving cars. And that scratched the surface a little bit, but I don't think it's fully exploiting the potential of synthetic data because it is not an integral part of a pipeline. It's like a one-off use case. The future I envision for that is actually, so imagine your Databricks, right? Or Snowflake. Everybody using Databricks or Snowflake, or everybody using like Amazon SageMaker or Amazon will have to have this as an integral part of their pipeline. The same way we think of like CI/CD is an integral part of your pipeline. The same way we think ML is part of your pipeline. Like 20 years of cloud is part of your pipeline, ML is part of your pipeline. You need to have a synthetic data part of your operational data pipeline, whether it's for compliance reasons, whether it's for privacy reasons, whether it is for making ML models more robust. That depends on the use case, depends on the sector. But every company across every vertical will need a synthetic data solution, right? In fact, I think NVIDIA or Gartner, I forget which one, said that in the future, like more than 70% of all ML models will be driven by synthetic data. And not just ML models. I mean, they were focusing on ML models, but you can actually think about every part of your enterprise product workflow or technology workflow. Sure. Everything from monitoring to responding to a customer to product and demos will need some form of synthetic data. Sure. And so it's almost like you forget it's there, right? It's like, oh, I call this API, it gives me this stuff, right? It becomes an integral, it's an integral API, data API for any pipeline that you have in the future. And that's the vision we are building towards. And we've always started from that vision, right? So we don't envision Rockfish or synthetic data as like, okay, it's a one-off. I just need like five fake rows. Please give it to me. Or I want to hash these 5 rows, give it to me, right? Yes, we will do that because that's easy. We can do that. But the ultimate vision is it's an integral part of every single data pipeline, right? So that's really what I think on the micro side. Now, flipping to your macro question, that's actually a great question. And I'm going to start like sort of being a little bit more open-ended here, right?
Yeah.
One thing I think we will need overall is, I think we will come back to building like I would say like a foundation of building more trustworthy systems. Okay, I think I still want to come back to think that today we are able to build like Amazon cloud APIs, all these cool things have made it dramatically easy to build stuff, but it's incredibly hard to understand what's going on, right? No human, no single software engineer, no single team is able to comprehend what's going on. They don't trust, they don't understand what's going on. So I think there's got to be a concerted future effort on what I would call explainable and trustworthy systems, not just AI, but across the board, right? Across the stack, because it's like it's getting untenable, right? I think that
I think in AI,
somebody,
you're
yeah,
saying there
especially
is
so.
data and dimensionality complexity, but even in the other systems, there's just system level complexity, which is
Oh,
hard to
totally.
explain.
No, yeah, exactly. Say whatever, like you say, oh, your Zoom call didn't go through. It's like, oh, what's going on? Is it authentication? Is it your VPN? Is it my ISP blocking it? There's so many things that could go wrong, right? And we don't understand it.
Yeah.
And that's one thing. Trustworthy, explainable, understandable systems is going to be a big theme.
Nice.
I would say second is actually that, again, I would say energy and cost will become a big theme. I think we've kind of like I would say energy cost, I would say like sustainability in that sort of broad bucket, right? Because it's still not, the verdict is still out there on where, if you're building these massive hyperscale data centers,
Yeah.
is it energy efficient? Is it the right way to do these things? Are they using renewable sources of energy? Are they sustainable, right? Not every place has the same level of power. That would, and right now we've kind of put that aside in the we are prioritizing sort of innovation and growth over sustainability at this point. And that's okay. That goes in cycles, right? But I would say like in 5 years, that will become a core factor.
Yeah.
Right. Now the third thing, you also asked about what's coming that we don't know about.
Yeah. What
right?
can we even start to imagine?
Yeah, I think that's a great question. That's a great question, right? I would say we've been used to a particular form of computing for a very long time, which is the sort of the traditional stored computer architecture that we all know. Like servers, cloud are just basically bigger versions of that. So that's coming. Now there are other forms of computing that we not even thought about. So there's actually some cutting edge work looking at like DNA storage and DNA computing. There's other work looking at quantum computing, right? And these are fundamentally different paradigms. They're not there yet.
Yeah.
Right. But if they are true, they are a game changer, because suddenly it's like, okay, you're getting some other order of magnitudes different. Some computations can be done much more efficiently in that. It's like the GPU moment for other kinds of things, right? So GPU was like, GPU was like, oh, you're doing the same thing over and over again. I can do it in a GPU and I can save you a lot of time and money, right? But imagine, and that is a very specific thing for like vectorized tensor type computations, but maybe DNA or quantum computing can do other things. And suddenly like quantum takes over, okay, the whole world of crypto will change. Right?
Yeah.
If DNA computing takes over, whole world of storage will change. Right. So, and then correspondingly, we'll have to change our software abstractions, our APIs, everything to that new computing model. And every time this new computing model, we need like language, compiler, the entire ecosystem to adapt, entire stack to adapt to that.
Interesting.
Yeah, I think we should continue to do that. The other thing I would think about is also what I would say is that we are fairly right now, I would say we're still sort of creating systems and infra fairly from the perspective of, I would say, the 1%. Right? So we still sort of, most of the things we do are from the perspective of the 1%, like the most privileged people. That's where the money is.
Yeah.
Unfortunately, fortunately, that's where the money is. And a lot of things you think about in like cloud computing, whatever, GPUs, is still from that point of view. I would say there will be a lot more sustained effort going further. It's like, okay, look, again, this is like democratization on another level, right?
Yes.
How do I democratize it? Not just for the 1% applications, but for all applications.
Yeah.
And without an infrastructure, right? So for example, I'm involved with a group of collaborators with our CMU Africa campus, right? And
Yeah.
that's the next frontier, right? That's
Yeah.
where the next technology, innovation, all these things is going to happen. It's already happening, right? But that's a very different set of ecosystem, very different set of challenges, right?
Yeah.
It's mobile first, no data center, very limited connectivity, a lot of local infra, very diverse, very heterogeneous use cases, right?
Yeah.
So, and I would say, how do you automatically build system or auto configure systems to be sustainable, effective, AI first for that completely heterogeneous architecture, right?
Yeah.
So, what are the digital public goods we need to build for that ecosystem? And I'm saying that's again very open-ended challenge. But I would say those are the four things that I would say. Okay, if I step back and ask me like, if I had all the time in the world, what would I work on? I would work on those four things.
No, thanks. Really, thank you for sharing that. That's fascinating insight. I think the last point I'm just trying to think through and articulate in a way to say, hey, this is about let's take compute in today's form or tomorrow's form, AI, synthetic data, all of that, and let's there is a responsibility, if I may say so, on all of us to take it to the real world for absolutely long-term sustainable impact, right? For the world at large, beyond enterprises, data infrastructure, etc., or just in the world that we live in. So that's a very fair and noble, thought for
Yeah, and
share.
absolutely, that world will be decentralized. That world will be disconnected.
Yes.
That world might be local first.
Yes.
Like the internet we know today is like very cloud first.
Correct.
I mean, that will not be the internet we know tomorrow, right?
Correct. Correct. No, very, very fascinating. Very fascinating. No, this has been an amazing conversation. I'm, taking so much in, and we can go on as well. I also want to be cognizant of time. Any headline thoughts from your side, right? I know you've already shared what excites you, what you're working on, right? But the next 20 years for you yourself, academia, industry, etc. Just with some parting thoughts, as well as maybe a shout out to Rockfish, as well as Conviva. How can people reach out to you? Just parting thoughts before I'll also check with the team if they have any questions for you.
No, I mean, as I said, this is an exciting time. Again, I personally feel incredibly privileged to be part of this like cutting edge innovation, both on the academic side, on the industry side, and being both an observer and an active participant in that sort of inflection and an agent, right? Not just an observer. So sometimes you're an observer, sometimes you're an agent of change. I think I have the privilege of being both and all three, and I'm grateful for that. And in terms of like, I think sort of people can reach me. I'm on LinkedIn. I'm on Twitter. I have multiple both. I'm reachable through my university email as well as my Rockfish email. I'm happy to share it, and people should reach out if there are like interesting use cases in synthetic data, streaming tech, or security, or any of these things where it's like again the overarching theme is like, look, how do you democratize hard tech for beyond the few? And in synthetic data, for Rockfish, it's doing democratizing synthetic data for enterprise use cases. And we was democratizing stateful stream processing. And at CMU, we're democratizing like hard technical problems and enabling the next generation of innovation at these different frontiers, right? And any of those things resonate with people, happy to share, happy to feel free to reach out. And always looking for new students, new collaborators. I mean, that's one of the cool things about this cross-pollination is, right? I would love to take credit for all the ideas I came up with, but the truth is it's the collaborators and that sort of cross-pollination that sort of creates that energy and that sort of virtuous feedback loop. So full credit to my students. I think the students and collaborators and co-founders, they keep me running, keep me active, and give me the energy even on a Sunday night.
No, obviously, and it reflects in the voice and how you're sharing that, the excitement and the energy. So thank you for that. So that's the shout out for everybody listening, right? You can reach out to Vyas. He's open for collaborators, students, entrepreneurs, ideas, right? In the multiple hats that he's wearing, right? And may the hats grow and may all of them, most of them find success, right? We're tracking you. So thank you so much for your time. Really enjoyed this fascinating conversation and the peek into both, history, sort of background, how you've arrived at this, what you're building, right? And there's just so much more. You rightly said, so privileged to have you on the show. Thank you so much. Very exciting. once again on a Sunday night, no less.
No, I'm just kidding. No. I mean, it keeps us going, right? I think, like I say, I think one of the things that says, if you love what you do, you're not working any single day. I've never felt like I've worked a single day. I've never had a boss. I've never actually had a real job. It's just a privilege to be doing what I'm doing. So thanks again for the opportunity, and thanks for having me and the great conversation. Thank you.
Great discussion. Tanush, Ankita, anything I'm missing that we want to add on?
No, Arjun. I guess you've covered most of the things. Yes, this is an amazing session so far. It's more like sitting in a class, listening to a professor talking about so many new interesting stuff, right? So I'm taking it with a lot of information for us to digest and work upon for our research as well. So thank you so much for your time. Thank you. Yeah. Ankita, you have any other?
Absolutely.
Yeah.
No, nothing. I think, Arjun, you've covered everything that we wanted to, but you gave us more than we asked for. Thank you so much for being so generous with your time, with your insights. Really grateful.
Oh, you're welcome. Thank you.
Thanks, everyone.
And hopefully,
signing off from Speciale.